Good morning, afternoon, or evening. This is Professor Rodriguez, and I have a tutorial here on the t-test, which is a measure of difference. So as you can recall, there are 5 important skill takeaways that I expect you to have as a result of taking this course. 1 is the ability to describe a sample or population, and the way you do that is with descriptive statistics. And those are broken down into 2 areas. 1, measures of central tendency or centrality, and those include things like the mean, commonly called the average, median, measure in the middle, and the mode, measure that occurs most often, those 3 being several important measures of centrality. And measures of dispersion. And we commonly use the range, sometimes the interquartile range, variance, and the most commonly used for the rest of the statistical world is the standard deviation. And a type of common or layperson's definition of a standard deviation is the deviation that could be considered standard or regular or normal. So 1 would be to be able to describe a population or a sample. 2 would be to compare 2 groups on 1 or more variables. That would be maybe the degree of empathy demonstrated by guys compared to the degree of empathy exhibited by women. And this is commonly determined by something called a t-test. 3, the third area would be to be able to compare 3 or more groups. Again, on 1 or more variables. 4 would be to determine if there is a relationship among variables. So that would be something like, do people with better IQs make better decisions? And 5 is to determine if there is a blank relationship among variables, causal relationship. So this is called a correlation. That is a joint relationship among pairs of variables. This is called a regression, and we'll talk more about how this came to be called a regression, but essentially it means that things that happen, if you look back at their past, that is, if you regress, you see that they have their origin in certain other kinds of variables or things happening. So here, this is the second part of this course, and we are directing ourselves at these two things, and these two things are comparison of two groups or more, comparison of two groups, and comparison of three or more groups. So this is a t-test, and as we'll recognize, this is called an ANOVA. So let's begin with the t-test. Let me take you to these three sets of normal curves. And let me ask you a question. Of these three sets of curves, which of them would you say are you more convinced that they represent different populations? I could clearly look at C and say, well, it looks like C is a fairly different population. So here's this group, and then here's this group, and there's very little, if any, overlap among these groups. So I would say these are fairly different. Then I would look at B, and I would say, oh, well, here's the group B, and here's a group B, and they are also different. On the other hand, I would look at this A and this A, and then I would say, oh my goodness, look at this. There's a significant commonality in A. So if you ask me which of these three represent different populations, I would say C and B. And the visual cues I have is that the two normal curves in B look like they're in different places relative to each other. C look like they're in different places relative to each other. And A has a significant amount of overlap. So, essentially, that's what we try to figure out numerically, statistically, when we take a t-test. Now, I want to point a couple things out to you on this visual area here, and that is, let me take this. So if you see the span between the center of the two normal curves in B. Now let's take that and let's take that over to the center of the two in A. Well, they're exactly the same distance apart. So the center of the two curves in A, the centers of the two curves in A, are exactly the same distance as the center of the two curves in B. Well, what's different about A and B then? What's different about A and B is that this distance from the center of the normal curves in A, this distance is a lot larger. You can see it's a lot larger than the distance of the center to the wing in B. Now let's compare A to C. With A to C has a different issue. And that is that the distance, the standard distance from the center to the wings in A is the same as the distance from the center to the wings in C. Well, that was kind of the problem comparing A to B, so let's look at this other measure, this B. So if we look at the distance between the two normal curves in B, you can see that that distance is a lot shorter than the distance from the two normal curves in C. And essentially, that's all we needed to make that determination. We needed two measures, two descriptive statistics, in order to make a determination whether those two normal curves truly represent different populations or the same population. And the two measures that we needed are called, one, the means, and two, the standard deviation. So, all of this t-test is designed to look at the mean and the standard deviation between two populations or samples to determine whether or not there is a difference. How might you do that? Well, what we're doing in both cases here is we are comparing the difference, a comparison of the difference between the two means, and then we want to compare that difference to what we might call typical or normal differences. This is done with something called a t-test. So a t-test is a comparison of the difference between the two groups, and then it compares that difference to what we might assume are typical or normal differences. So, if the difference between two groups exceed what you might believe are normal differences, then you would say, oh, well, we found a difference that is truly significant. It's not a normal difference. It exceeds a normal difference. So, therefore, since it exceeds a normal difference, by some measure, whatever our standard is going to be, if it exceeds that normal difference, then we are going to call it truly different. That, my friends, is a t-test. So let's take an example of a scenario where we might use a t-test. So let's take a scenario where we are trying to compare two groups, and we'll see how this plays out arithmetically, mathematically. So, let's say we're given this task by the VP of HR, and the task is this. We have a bunch of employees, we have a bunch of employees, and we have their salaries, and we're trying to make a determination, are their salaries the same or are they different for both of these groups? And we're told, in fact, we're told that these groups are males and females. And we're told here's a male who makes $61,000 a year, and here's another male who makes $53,000 a year, another male who makes $59,000 a year, another male who makes $55,000 a year, and another male who makes $57,000 a year. And then here's a female who makes $50,000 a year, and another female who makes $48,000 a year, and another female who makes $56,000 a year, and another female who makes $54,000 a year, and another female who makes $52,000 a year. Now, actually, when we were given these numbers, and males and females were all mixed in together. Maybe they were organized by last name or company ID. So the first thing we have to do, of course, is where, in terms of the interest, the grouping category that we are interested in, we would separate them according to those categories. So in this case, it's males and females. Okay, now let's look at this idea, what we're trying to do. We're trying to compare the differences between the two means of the groups and compare that difference to what are typical or normal differences. So still, from what we know about statistics, we're able to do that. We're able to compute the average for females. So we would total this. This is 14. This would be 20 to 11, 21, 26. So 26 divided by 5 numbers. So this women have an average of 52,000. And then what's the average for males? 4, 13, 13 and 12 is 25. 2, so it's 13, 23, 28. Divided by 5, 5, 7. So the average salary for these 5 guys is 57,000. And we're assuming, of course, that we randomly selected these folks from the population of all of our employees. So what do we know now? We know if we compare the differences between the two means. What's the differences between the two means? 57 minus 52. It's the difference between the two means. Now we want to compare that to what we might call normal standard differences. And we know that normal standard typical differences we refer to as the standard deviation. And the way we compute the standard deviation is by taking the difference of all of the numbers from their means. So that would mean the difference between this 61 and its mean of 57 is 4. And then we would square that 4 to get 16. And the difference between 53 and 57 is 4. And we would square that 4 to get 16. And the difference between 59 and 57 is 2. We would square it, get 4. The difference between 55 and 57 is 2 units. Square it, get 4. And the difference between 57 and 57 is nil. So now we have the squares here, right? The square differences. And now down here we would total these up. We would total these up and get 40. And that would not be the square differences, that would be the sum of the square differences, most commonly just referred to as SS, or sum of squares. So the sum of squares of the group 1, so the sum of squares of the group 1 people is 40. What about the sum of squares of the group 2 people? Well, their mean is 52, so the difference between 50 and 52 is 2. 2 units squared, you get 4. The next 48 and 52 is 4 units squared, you get 16. The next 56 versus 52 is 4 units squared, you get 16. The next 54 versus 52 is 2 units squared, you get 4. The next 52 is 52, it's not. So these are the square differences, and now, just like we did with this first category of guys, we're going to take the gals and we're going to say that their total, that is sum of squares, equals 40. So we're going to divide this distance up top in the numerator, 57 minus 52, by this formula here. And this formula is going to be the sum of squares in group 1 plus the sum of squares in group 2, but we're going to divide this by the degrees of freedom in group 1 and the degrees of freedom in group 2. And the way you get degrees of freedom is you take the number of units within the group that you're talking about and you subtract 1. So in the case of group 1, we have 5 units, that is 5 people, and we're going to subtract 1. And to that, we're going to add the same number relative to group 2, which is 5 units minus 1. Now a t-test, as you quite realize, the more of a sample that you would select from a population, the more accurate or the more trustworthy your numbers would be. To the point where once you get right around 30, you're pretty much in the clear. Now in this case, we have only 5 members of each group that we sampled. So even logically, it makes sense to believe that we can trust these numbers to a lesser degree. And statistical analysis, of course, wants to consider the importance of that. So we're going to have a multiplier here that we're going to multiply this by. And all you have to remember here is that this multiplier, and it's an adjustment, and that's the way you should think of it. It's an artificial adjustment that makes sense. And this is what it looks like. N plus N over N times N. So in this case, it would be 5 plus 5 over 5 times 5. And in this case, what are we doing? We're comparing the differences between the two groups to what we might consider normal differences adjusted for the size of our samples. And the rest of this is simply arithmetic. So here we have the 57 minus 52 over the square root of 40. Now we're doing this here. 40 plus 40 is 80, divided by 5 minus 1 is 4, plus 5 minus 1 is another 4, so that's 8, times 5 plus 5 is 10, 5 times 5 is 25. So we recognize 80 over 8 as 10, and 10 over 25 as 2/5, and then we divide 5 into 5, 5 into 10, so that leaves us with a denominator of the square root of 4 and a numerator as 5, or 5 over the square root of 4 is 2. So this t, which is what we're computing here, is 2.5. And what does that mean? That means the weight of the differences, average differences between the two groups, 5 units, is 2.5 times the weight of what you would consider normal differences, which is this 2. So it exceeds, the 5 exceeds the 2, it's 2.5 times the 2, so t is 2.5. So what does that mean? That means in this curve, we know 1 standard deviation, 2 standard deviations, 1 standard deviation, 2 standard deviations. So this is 95%. So this is more, 2.5 standard deviations is more than 2 standard deviations, right? So it means that the differences between these two groups is back into this category, which means you have significant evidence that the two groups are different. And that is how you calculate a t-test. That is the meaning of a t-test, and that is the logical thinking that goes behind a t-test. So let's take an example of this and what you would do in SPSS. So this is assuming that we have an entering class of management trainees, and we have given them the first management trainee test. There are 18 people in this class, and we want to do a t-test because we want to compare two groups. That is, we want to compare the males to the females to see who is doing better in terms of the course at this point. So what we would do here is we have this data, and we can see that we have exam, that's supposed to be exam 1. It looks like exam 1100 in there. And then we will go to analyze. And of course what we want to do here is we want to compare the means, and we want to do an independent sample t-test. That is, we're not pairing, these people are not paired up by any in any way. This is not a one sample t-test. It is an independent samples. So we would click on independent samples t-test. And what do we want to test? We want to test exam 1, so we'll put exam 1 in the test variable, and then it asks for the grouping variable, and the grouping variable is sex. And as you can see, scale variables in SPSS have this ruler icon to the left of them in that box, and variables that are categorized, you can see they have like these Venn circles, and so those are categorizations. In this case, sex is the grouping variable. Now we would say define groups, and group 1 is defined as a 1, and group 2 is defined as a 2, because that's how I coded them. And let's look at options. Is there anything we want to do here? No, nothing. So we would just click on OK. And once we click on OK, this is the output that we get. So it tells us that there were 12 females and 6 males in this group. And the average for the females was 86.2, and the average for the males was 53.8. And we're wondering this, with this fairly small, even if it's representative, group of males and females, is there a significant difference between the males and the females? And immediately what we should be looking at down here is we should be looking at this significant two-tailed test. So you see the significance, two-tailed significance is 0.527 with equal variances assumed, and an even less likely 0.566 with equal variances not assumed. So what we would conclude here is that we have not found significant evidence to justify our hypothesis. Now let's take the example that we just did by hand, and that is that there were 5 females with wages of $50,000, $48,000, $56,000, $54,000, $52,000, and there were 5 males with incomes of $61,000, $53,000, $59,000, $55,000, and $57,000. So as you can see here, we have a data file that was created with those incomes. I put in those incomes. I put in females as 1s, males as 2s, and now we will go to analyze. Again, we want to compare the means. We want to compare the means between these 2 independent samples, and we want to test for the variable of wage, and we want our grouping variable to be the variable 1, which is gender, which is 1 and a 2. So you can see I defined the groups as 1s and 2s, which is consistent with my coding. And then I click on OK, and now the result is this table right here, where you can see that the mean for females is 52, the mean for males is 57, and the t-value is minus 2.5, minus because the way we input females as a 1 and males as a 2, we subtracted the 52 from the 57, which made that formula for t negative, right? So 52 minus 57 is minus 5. Our degrees of freedom is 8, which is 5 minus 1 for the one side, the males, 5 minus 1 for the other side, the females, so degrees of freedom is 8. And you see the significance, two-tailed significance, is 0.037. And what does that mean? That means our conclusion then is that we have significant evidence that males and females are paid differently. Notice what we can't say, although it makes obvious sense, what we cannot say is that therefore men on average exceed women by $5,000, that men make 57 and women make 52, because that is not what we set out to test. What we set out to test is that there were differences. There are differences, and that was in fact what we proved. So we conclude for our hypothesis, and against. Another video on ANOVA will be coming up shortly. Please be on the lookout for it. It will have approximately the same kind of structure as this one. Bye for now.